The heading is dot product in 3D. Now, as promised, a lot of the things that we've been covering so far in Extension 2 vectors have been things that you knew from Extension 1 vectors in 2D, and then we've gone ahead and we've added another dimension to them, right? And that's going to be today's lesson in some measure, but I want to push on that. This is one of those wonderful places where you gain this qualitative difference when you move into 3 dimensions with something like the dot product that just isn't there in 2 dimensions. So we'll get to that. Slight spoilers for what's coming ahead. Before we get there though, as I've just established, right, you can't understand the dot product in 3D well unless you know what's going on with the dot product in 2D. And I know for a small subsection of you, this will look familiar, but for several of you, it will not. So I'm just going to give you my 90-second version of how I think about the dot product. And there's so many different ways that you can think about this. Whichever way works for you, I think you need to have some kind of metaphor in your head, whether it's, playing a video game or holding a bucket to rain or thinking about a windy day on the beach. Otherwise, you're just crunching numbers, right? And we do not want you to be people we don't want you to be computers. Computers used to be people. Like that was their job because we didn't have objects that could do the calculations that we needed to rely on human beings who could compute things, right? We want to go past the computation and think about what does it mean. So, imagine yourself on the beach, trying to walk toward the water. And importantly, it doesn't matter where in the water you land, you're just trying to get wet, right? So you're just trying to get out there, okay? Now, if it's a windy day, which it often is at the beach, right? Then the question that the dot product answers is, how much is the wind swirling around you? How much is it helping you towards the water? Or how much is it hindering you away from your goal, away from the water, right? Now, clearly it depends on 2 things, and you can see why this relates to vectors, right? How much the wind is helping or hindering you depends on which way is the wind blowing, what's its direction, and how much force is the wind applying? I guess what is its magnitude, right? So in the case where, and this is usually the case, right? If the wind is coming out